Stop walking past these 7 rocks because every single one of them is pointing directly to gold deposits worth thousands of dollars. I'm talking about indicator minerals that professional prospectors use to locate gold-bearing zones before they even pull out their metal detectors. In the next 30 minutes, you're going to learn exactly how to identify these specific rocks in the field, what they reveal about gold deposits beneath your feet, and the precise testing methods that separate wishful thinking from actual discoveries. Here's what most people don't know. Gold doesn't just appear randomly in nature. It travels with specific companion minerals that act like geological road signs. Music, and today I'm showing you all 7 of them, plus the field test you can perform with less than $15 worth of equipment. Rock number 1, music, quartz with iron staining. The first rock you need to memorize is iron-stained quartz. And this is the most reliable gold indicator on this entire list. Picture white or milky quartz covered with rusty orange, red, or brown staining that looks like oxidized metal. That iron staining is the footprint of iron sulfides like pyrite that weathered away. And those sulfides frequently occur alongside gold in hydrothermal vein systems. Here's why this matters. Gold forms when superheated mineral-rich water rises through bedrock cracks. As it cools, quartz crystallizes first, trapping iron sulfides and gold particles. When sulfides oxidize at the surface, they leave rust-cold staining. The gold doesn't oxidize. It stays locked in the quartz or gets released as the rock erodes. Look for quartz with a glassy shine and irregular rust-colored patches concentrated in fractures and cracks, not uniform coating. The staining ranges from bright orange to deep brown or black. Here's your field test. Compare the weight to unstained quartz. If it feels unusually heavy, metallic minerals might be present. Find entire zones of stained quartz and creek beds where quartz veins cut through bedrock. That's where you want to start panning downstream. Music, or rock number 2, magnetite, commonly called black sand, is your second critical indicator. This rock appears as heavy metallic black grains that stick to magnets, and it concentrates in the exact same places gold settles because they have similar densities. Professional miners know that wherever you find black sand accumulating in quantity, gold is usually hiding right underneath it. Magnetite, music, has a specific gravity of 5.2 compared to gold's 19.3, but both are significantly heavier than regular sand at 2.65. During stream transport, these heavy minerals settle together in low-pressure zones, inside bends of creeks, behind large boulders, and in bedrock crevices. That's the secret experience prospectors use. They follow the black sand trails to find gold concentrations. Here's your identification method. Music, magnetite appears jet black with a metallic luster when fresh, sometimes with a dark gray streak. Take a small magnet, even a refrigerator magnet works, music, and pass it over suspected black sand. Real magnetite will jump toward the magnet instantly. The individual grains are angular rather than rounded, music, typically ranging from fine powder to small granules. In your gold pan, black sand creates problems because it's heavy enough to stay with gold during panning, making final cleanup difficult. But that's actually good news. It confirms you're processing material from a gold-bearing zone. Look for black sand accumulations in stream gravels, especially in areas where water velocity decreases. Ancient stream terraces above current water levels often contain rich black sand deposits that prospectors overlook. Rock number 3, pyrite, music, fool's gold. Let's talk about pyrite or fool's gold and why finding it is actually excellent news despite its reputation. Pyrite is iron sulfide with a brassy yellow color and metallic luster that beginners confuse with real gold. But here's what most people don't know. Pyrite and gold form together in the same hydrothermal environments, making pyrite a reliable pathfinder mineral for gold deposits. The key is understanding that while pyrite itself isn't valuable, its presence confirms you're in a mineralized zone where gold likely exists. Professional prospectors actually get excited when they find pyrite because it indicates sulfide-bearing veins that often contain gold as an associated mineral. In many gold districts, microscopic gold particles are actually locked inside pyrite crystals. You can't see it, but it's there. Here's how to identify pyrite correctly. It forms distinctive cubic or pyohedral crystals with flat striated faces. The color is brassy yellow, not the warm, buttery yellow of gold. Pyrite has a hardness of 6 to 6.5 on the Mo scale, meaning it scratches glass easily, music, while gold at 2.5 to 3 is soft and malleable. Strike pyrite with a hammer and it produces sparks with a sulfur smell. Gold just deforms. The streak test is definitive. Scratch pyrite on unglazed porcelain and it leaves a greenish-black streak, while gold leaves a golden-yellow streak. Look for pyrite and quartz veins, especially those with visible iron staining. Cubic crystal formations jutting from quartz are classic indicators you're near gold-bearing structures. Rock number 4, hematite. Music, your fourth indicator is hematite, an iron oxide that appears in several forms that all point toward gold potential. Hematite ranges from metallic silver gray to earthy red, and it frequently occurs in oxidized gold-bearing zones where iron sulfides have weathered. That metallic silvery variety called specular hematite looks like stacked metallic plates and often forms in the same hydrothermal systems as gold. Here's the geological connection. When gold-bearing pyite oxidizes near the surface, it transforms into hematite and elmenite, creating what miners call a gossan or iron cap. These goins sit directly above sulfide ore bodies, including gold deposits. Historic miners used gossans as exploration targets because they are visible from distance as rusty red or brown zones on hillsides. Identify hematite by its characteristic blood red streak on porcelain. This is diagnostic regardless of the specimen's external color. Specular hematite has a metallic luster with silver-gray color and distinctive platy crystal structure. Earthy hematite appears as soft powdery red material that stains your fingers. Both varieties are moderately heavy with a specific gravity around 5.3. In the field, look for hematite in weathered quartz veins, as red staining on rocks near old prospect pits, or as metallic plates and fractures. Areas with significant hematite accumulation, especially combined with quartz fragments and elmenite, indicate you're in an oxidized zone above potential sulfide mineralization. Check downstream gravels for hematite pieces. They'll lead you back to the source vein. Rock number 5, galena lead sulfide. Rock number 5 is galena. And this is where you need to pay serious attention because galena frequently contains significant silver values and commonly associates with gold in polymetallic vein systems. Galena is lead sulfide with a distinctive metallic gray color, extreme density, and perfect cubic cleavage that makes it unmistakable once you know what to look for. Here's why galena matters for gold prospecting. Many historic gold districts also produce lead and silver from the same vein systems. The metals precipitated together from hydrothermal fluids with galena often containing microscopic silver and gold inclusions. When you find galena in quartz veins, you're looking at evidence of significant hydrothermal activity, exactly the environment where gold deposits form. The identification is straightforward. Galena has a bright metallic silver-gray color when freshly broken, though it tarnishes to dull gray quickly. The defining characteristic is perfect cubic cleavage. Break a piece and it shatters into perfect little cubes and rectangular blocks. The density is shocking. Galena has a specific gravity of 7.5, making even small pieces noticeably heavy. It's soft at hardness 2.5, so a fingernail scratches it easily. Look for galena and quartz veins cutting through country rock, particularly in areas with known historical mining. It often occurs with pyite, thallarite, zinc sulfide, music, and chalcopyrite, copper iron sulfide. When you find galena, examine the surrounding quartz carefully for gold specks. Use a small jeweller's loupe because gold associated with galena is often fine-grained and easy to miss with the naked eye. Rock number 6, arsenopyrite. Now we're getting into advanced territory with arsenopyrite and arsenic iron sulfide. That's one of the strongest gold indicators you can find. Professional prospectors know that arsenopyrite and gold are intimate companions. Many of the world's richest gold deposits contain significant arsenopyrite, and the gold is often locked within the arsenopyrite crystal structure itself. Here's the crucial knowledge. Arsenopyrite forms at similar temperatures and pressures as gold during hydrothermal events. In many gold districts, microscopic gold particles are actually contained within arsenopyrite crystals, invisible to the eye, but detectable through assay. When arsenopyrite weathers and breaks down, it releases that trapped gold into the surrounding material. Identification requires care because arsenopyrite looks similar to pyrite. The key difference is, arsenopyrite has a silvery white to steel gray color rather than brassy yellow, and it forms distinctive elongated crystals rather than cubes. The crystals often have a diamond-shaped cross-section. When struck with a hammer, arsenopyrite produces a strong garlic odor from the arsenic. That's diagnostic, but handle it cautiously as arsenic compounds are toxic. The hardness is 5.5 to 6 on the MO scale, and it leaves a black streak on porcelain. Look for arsenopyrite in quartz veins, especially milky white quartz in metamorphic rock environments. It frequently occurs with pyrite, chalcopyrite, and visible gold. If you find arsenopyrite-bearing quartz, that material deserves serious sampling and assay because the gold might be submicroscopic. Always wash hands thoroughly after handling arsenopy specimens. Rock number 7, chalcopyrite, copper iron sulfide. The seventh and final indicator rock is chalcopyrite, a copper iron sulfide with a distinctive brassy gold color that often occurs in gold-bearing vein systems. Here's what makes chalcopyrite significant. It commonly contains trace amounts of gold and silver as impurities, and many ferri-copper gold deposits worldwide are mined primarily for gold, even though chalcopyrite is the dominant sulfide mineral. Chalcopyrite has a brassy yellow color similar to pyrite, but there's a subtle difference. Chalcopyrite has a slightly greenish or peacock-colored tarnish that develops on weathered surfaces, while pyrite stays consistently brassy yellow or turns rust-colored. This iridescent tarnish is your key identification feature in the field. The hardness is 3.5 to 4 on the MO scale. Softer than pyrite, 6 to 6.5, meaning a steel knife scratches chalcopyrite but won't scratch pyrite. The streak is distinctive greenish-black on porcelain, never the brownish streak of pyrite. Chalcopyrite is brittle and breaks irregularly rather than forming the cubic crystals of pyrite. Here's the gold connection. Chalcopyrite typically forms at slightly lower temperatures than pyrite during hydrothermal mineralization, often precipitating alongside gold in the outer zones of vein systems. In epithermal gold deposits, those formed at shallow depths with lower temperatures, chalcopyrite is a common associate of high-grade gold ore. Look for chalcopyrite and quartz veins, particularly those with multiple sulfide minerals present. The presence of several different sulfides together, pyrite, chalcopyrite, galena, arsenic, indicates a complex hydrothermal system with excellent gold potential. Check chalcopyrite-bearing specimens carefully with a loupe for visible gold specks. Location strategy and geological context. Music. Now, here's where it gets interesting. Knowing these 7 rocks is worthless unless you understand where to actually find them. Music, gold and its indicator minerals don't randomly appear in just any rock formation. They concentrate in specific geological environments that you can learn to recognize even without formal training. First, understand that most accessible gold occurs in what geologists call lode deposits, or the placer deposits derived from them. Lode deposits are the original sources, veins and zones where gold crystallized from hydrothermal fluids in bedrock. Placer deposits are secondary concentrations where erosion liberated gold from lode sources and gravity concentrated it in stream sediments. Your indicator rocks point to lode sources. When you find quartz veins with iron staining, pyrite, arsenopyrite, or the other indicators, you're looking at the actual bedrock source where gold formed millions of years ago. This is critical information because it tells you where to focus placer prospecting efforts downstream from these source veins. Here's the practical strategy. Prospect in areas with known historical mining activity. Old prospect pits, abandoned mines, and historical gold districts exist because prospectors already did the hardest work of locating mineralized zones. Modern recreational prospectors can legally access many of these areas and find material overlooked by previous miners who lacked modern knowledge and tools. Look for exposed bedrock in creek beds, road cuts, and hillside outcrops. Weathered oxidized rock faces often reveal quartz veins more clearly than fresh surfaces. The quartz appears as white, gray, or rusty-colored bands cutting across darker country rock at various angles. These veins range from pencil-thin to several feet wide. But does that mean you can find these indicator rocks anywhere? Absolutely not. Gold deposits require specific tectonic and geological conditions. Most gold in North America formed in orogenic belts, zones of mountain building and tectonic compression, or in volcanic arc settings where subduction created the heat and fluid flow necessary for mineralization. Practically speaking, focus your efforts in known gold-bearing regions. In the western United States, that means the Sierra Nevada, the Rockies, the Black Hills, and the Southwest Desert Ranges. In the east, check the Appalachian region, particularly the Carolina Slate Belt. In Canada, the Canadian Shield hosts numerous gold districts. In Australia, Victoria, and Western Australia are classic gold regions. Within these broad areas, narrow your search to specific rock types. Gold commonly occurs in metamorphic rocks like schist, slate, and greenstone because these formations experience the temperature and pressure conditions favorable for gold deposition. Intrusive igneous rocks like granite and diorite also host gold, particularly where they contact metamorphic rocks. These contact zones create thermal gradients that drive hydrothermal circulation. Here's what professional prospectors do. They study geological maps available free from government geological surveys. These maps show rock formations, fault lines, and known mineral occurrences. Fault zones are particularly important because faults create fractures that channel hydrothermal fluids. Gold veins frequently follow fault structures, practical methods, and field testing. Let me show you exactly how to test these rocks in the field with less than $15 worth of equipment. This is the validation system that separates real discoveries from wishful thinking. And you can perform every single test at the location where you find these specimens. First, invest in 3 essential items. A small magnet and glazed porcelain tile, the back of bathroom tile works perfectly, and a steel file or knife. Total cost under $10 at any hardware store. These simple tools perform the critical tests that identify indicator minerals definitively. The magnet test comes first. When you find black sand or dark metallic minerals, pass your magnet through the material. Music, magnetite sticks strongly and immediately. But here's the technique experienced prospectors use. Lift the magnet slowly and watch how the particles behave. Magnetite forms chains and spikes reaching toward the magnet while non-magnetic black minerals like ilmenite stay put. This instant differentiation saves hours of processing worthless material. The streak test is your definitive identification method for metallic minerals. Scrape your specimen firmly across the englazed porcelain. You're literally grinding off a tiny amount of powder to see its true color. Pyrite leaves greenish-black, hematite leaves blood-red, music and real gold leaves golden yellow. The streak never lies because it shows the true color regardless of surface tarnish or weathering. Here's the hardness test technique. Take your steel knife and attempt to scratch the mineral. Press firmly and draw the blade across the specimen. Music or real gold is soft. The knife scratches it easily and you'll see the scratch shine. Pyrite is hard. The knife won't scratch it at all. Instead, the pyrite might scratch your knife. This single, music, test instantly separates gold from pyrite, ending the fool's gold confusion permanently. For quartz veins, perform the weight test by comparing similar-sized pieces. Pick up a chunk of iron-stained quartz in one hand and plain quartz or common granite in the other. Close your eyes and feel the weight difference. Metallic minerals add density that's perceptible. This kinesthetic learning trains your hands to recognize mineralized specimens automatically. The hammer test reveals crystal structure and composition. Tap suspected pyrite or arsenopyrite crystals sharply with a rock hammer or heavy wrench. Pyrite produces sparks and a sulfur smell. Arsenopyrite produces the distinctive garlic odor. Galena shatters into cubic fragments. Gold just deforms and flattens because it's malleable. Never hammer specimens you want to keep intact. This is strictly a field identification technique. Now, here's the part that surprises most people. You can perform a specific gravity test in the field with just a water bottle and a scale. This technique confirms dense metallic minerals definitively. First, weigh your specimen dry. Then fill a container to the brim with water. Submerge the specimen and collect the overflow water. Weigh that overflow water. Divide the specimen weight by the overflow water weight. That's specific gravity. Gold has a specific gravity of 19.3, meaning it's 19.3 times heavier than an equal volume of water. Pyrite is 5.0. Magnetite is 5.2. Galena is 7.5. If your calculation shows specific gravity above 15, you've got gold, platinum, group metals, or tungsten. Between 5 and 8, you've got base metal sulfides worth investigating. Below 5 is likely quartz, feldspars, or silicate minerals. The acid test requires household vinegar for safe field use. Music, carbonate minerals like calcite fizz vigorously in vinegar, helping you distinguish calcite from quartz. This matters because calcite sometimes occurs in veins and can fool beginners. Music, quartz doesn't react at all with vinegar. No fizzing, no dissolution, nothing. If it fizzes, it's not quartz. Here's what most people don't know. You can perform a simple gold pan test on crushed indicator rocks to check for gold content. When you find promising quartz with sulfides, break off a fist-sized sample only where legally permitted on claims you own or have permission to prospect. Crush it thoroughly using a hammer against a solid steel surface. Crush it fine, the consistency of coarse sand. Pan this crushed material carefully using standard gold panning technique. Work slowly, removing the lighter quartz and silicate minerals until only heavy concentrate remains. Look for bright, malleable metallic particles that streak golden yellow. Even tiny gold specks confirm that your indicator rocks are leading you to payable deposits. Advanced recognition and quality assessment. Wait until you see what happens next. This is where we separate industrial-grade finds from specimens worth significant money. Not all gold or gold indicators have equal value, and recognizing quality in the field maximizes your prospecting efficiency. Shape and formation matter enormously. Gold occurs in several distinct forms, each indicating different depositional conditions. Crystalline gold forms octahedral or dodecahedral crystals, typically in quartz veins where growth occurred slowly in open cavities. These specimens have exceptional collector value. A thumbnail-sized crystal cluster sells for hundreds or thousands of dollars. Wire gold and dendritic gold represent another high V-value form. These delicate branching structures formed when gold crystallized in narrow fractures or grew on host mineral surfaces. Wire specimens are fragile but spectacular, commanding premium prices from mineral collectors. If you encounter wire gold and quartz, extract it extremely carefully to preserve the crystals intact. Nuggets represent the most famous gold form, worn rounded pieces transported by water and shaped by tumbling in streams. True nuggets are rare in most districts, but when found, they typically indicate rich upstream sources worth investigating. A nugget shape tells its transportation history. Angular edges indicate short transport distance from the source, while smooth rounded shapes indicate extensive stream transport. Fine gold and flour gold appear as tiny particles barely visible to the naked eye. This is the most common gold form in placer deposits. While individual particles have minimal value, fine gold can occur in sufficient quantity to make commercial recovery viable. Many successful prospectors make consistent money, working fine gold deposits that others overlook. Here's the quality assessment technique professional prospectors use. Examine gold color carefully. Pure gold has a rich, buttery yellow color. Electrum, natural gold, silver alloy, appears paler, more silver yellow. The silver affects value. Pure gold trades at full spot price while electrum containing 30 to 40% silver has correspondingly lower value. In the field, you can't determine exact purity, but color gives strong indications. For indicator minerals, quality assessment focuses on sulfide abundance and vein characteristics. A quartz vein with 5 to 10% visible sulfides by volume indicates strong mineralization worth systematic sampling. Veins with just occasional sulfide specks may be barren or contain only traces of gold. The more sulfides present, generally the better your chances of economic gold content. Crystal size provides clues about formation conditions. Coarse grain sulfides, pyite crystals several mm across, indicate slow cooling and growth in open fractures, conditions that often favor gold deposition. Fine-grained sulfide suggest rapid crystallization that sometimes produces lower gold values. This isn't absolute, but it's a useful preliminary indicator. Alteration patterns surrounding veins offer critical information. Look for clay alteration, bleaching, or silicification in the rock immediately adjacent to quartz veins. These alteration halos, sometimes extending several feet from the vein, indicate that hot, acidic hydrothermal fluids thoroughly permeated the host rock, exactly the conditions that deposit gold. Comprehensive validation and home testing. Here's the complete validation system that gives you definitive confidence in your finds. These techniques progress from simple field tests to more sophisticated home evaluations, providing multiple confirmation methods that eliminate doubt. The nitric acid test provides chemical confirmation of gold, but requires careful handling. Purchase dilute nitric acid from a jewelry supply company. Never use concentrated acid. Place your suspected gold particle on white porcelain and add one tiny drop of acid. Base metals dissolve and react. Gold remains completely unaffected. Silver produces a white silver nitrate cloud. This test is definitive but requires appropriate safety precautions. The electronic gold tester offers foolproof identification for about $40. These devices measure electrical conductivity, which for gold is distinctly different from pyite, brass, or other lookalikes. Touch the probe to your specimen and the display indicates gold presence instantly. Professional prospectors use these testers to evaluate concentrate quickly. The Archimedes specific gravity test performed at home with precision scale and distilled water gives exact measurements. Weigh your specimen dry to 0.01 g precision. Suspended in distilled water using fine wire attached to the scale recording the submerged weight. Calculate specific gravity using the formula dry weight divided by dry weight minus submerged weight. Results between 15 and 20 confirm gold or platinum group metals definitively. Visual examination under magnification reveals critical details invisible to the naked eye. A 10 times jewelers loop costs $5 and transforms your identification capability. Real gold shows distinctive features. Hackley fracture surfaces, malleability evidence where the specimen bent rather than fractured, and characteristic metallic luster that doesn't diminish under magnification. The Bloob concentrator provides another validation level. This specialized gold panning device uses water flow and concentric rings to separate materials by density with exceptional efficiency. Process your concentrates through the blue bowl. Gold and platinum group metals accumulate in the center while pyrite and base metal sulfides wash to outer rings. The separation is dramatic and visual. Black light examination helps identify certain minerals and can reveal treatment in questionable specimens. Natural gold doesn't fuse under UV light, while some synthetic materials do. Certain mineral inclusions in quartz fuse distinctively, helping confirm specimen identity and natural origin. The thermal conductivity test leverages gold's exceptional heat transmission. Touch an ice cube to your specimen and to known copper or brass. Gold transfers heat so efficiently that ice melts noticeably faster than on other metals except silver and copper. This isn't definitive alone, but adds confirmation when combined with other tests. Fire assay represents the ultimate validation technique, music, providing exact gold content measurements. Commercial assay labs process samples for $30 to $50, crushing, mixing with flux, melting at high temperature, and measuring the resulting gold bead. If you found significant material deserving commercial evaluation, fire assay removes all uncertainty. X-ray fluorescence. XRF analysis offers non-destructive elemental analysis. Some rock shops and mining suppliers provide XRF testing services immediately identifying all elements present. This technology confirms gold presence and provides percentage composition. Invaluable for assessing electrum or gold-silver alloys. Success indicators you need to recognize. When multiple indicator minerals occur together in the same location, your probability of gold presence increases exponentially. A quartz vein containing both pyrite and arsenopyrite with iron staining deserves serious attention and systematic sampling. Visible gold in specimens obviously confirms a discovery. But here's what to look for. Music, bright metallic yellow color that doesn't tarnish. Distinct malleability if you can test a particle. Extreme density noticeable even in tiny specks. Occurrence in quartz or associated with sulfide minerals. Location in an area with appropriate geology and perhaps historical mining activity. Documentation practices protect your interests and improve future prospecting. Photograph every significant find with scale reference and location markers. Record GPS coordinates precisely. Note associated minerals, host rock type, vein orientation, and any nearby prospects or claims. This data becomes invaluable when you find a rich zone and want to expand systematic sampling. Quantity assessment requires practical thinking. Finding one gold-bearing quartz specimen is exciting, but not necessarily economic. Finding an extensive zone of gold-bearing quartz represents potential value. Experienced prospectors distinguish between detection limit gold traces present but not economically recoverable and payable deposits where concentration justifies extraction costs. The path from finding indicator minerals to recovering significant gold involves systematic progression. First, identify the indicator minerals. Second, trace them to source veins or concentrated placer deposits. Third, sample systematically to determine grade and extent. Fourth, evaluate whether the deposit justifies further work or professional development. Subscribe and hit notifications because this channel delivers actionable prospecting education every single week. No fluff, no exaggeration, just proven techniques you can implement immediately to find gold and valuable minerals. Music, your assignment before the next video. Visit one location this week and collect samples of at least 3 rocks we discussed today. Photograph them, perform the field tests, and leave a comment sharing what you found. This active participation transforms passive watching into practical skill development. The indicator minerals are everywhere, waiting for someone with trained eyes to recognize their significance. That someone is now you. Get out there, apply these identification techniques, and discover what's been hiding under your feet all along. I'll see you in the next video where we're crushing gold-bearing quartz and extracting visible gold using methods you can replicate at home for under $50.